Welcome student to the series of lecture on LangGraph. In the last lecture, we introduced the concept of persistence, and that was a very powerful discussion. So if you haven't watched that lecture, I would recommend that you go back and watch it because there we actually understood why persistence is needed. And today we are going to implement persistence, and you will feel persistence in action. First of all, whenever we talk about persistence in LangGraph, I'll repeat this from the last lecture. There are three ingredients. That is, number one is state, what data we are carrying. Number two is check pointer, where we store the progress. It stores both the progress of the workflow, where the workflow is right now, and the data associated to workflow. Number three is thread ID, whose data we are storing and whose data we want to or we need to resume. Okay, so we'll jump into the code, we'll jump into the implementation, but before that, let's feel that what we are trying to do. We'll build a very simple two-step workflow. So there would be step one and step two. Okay, very simple two-step workflow. In step two, I will intentionally make the system crash. So we are simulating a production-like failure. So in step two, I'll make a simulation of failure, of a crash. Now think of this scenario. Step one has already been executed for, say, a user one. We are calling this user as user one. Then in step two, the system crashes for user one. Now, here is the important part. When we resume the system in the implementation today for user one, it will not rerun step one. It will not rerun step one. It will resume from step two. It will directly continue from step two. But if I run the same system for another user, say user two, the system will start fresh. It will go from step one, step two, and complete the execution. It will not fail because it failed only for user one and it is resuming for user one from step two. That is what we will see today happening. Okay. And how this will happen? Because the system understand that the crash happened only for user one and no history exists for user two. Okay. So in this lecture, we are going to simulate this entire scenario. We'll crash the system and then we will see how the checkpointers helps to resume from step two for user one and how thread ID helps the system identify which user execution to resume. Perfect. Let's jump directly into the implementation. Step one is importing the libraries. Okay, I'll not talk about typedict. I'll not talk about state graph because we discussed about these two classes in previous session in detail. Important is, which is new in this session, is MemorySaver. First of all, let's see, we are using LangGraph, and in LangGraph, there is a module which is checkpoint.memory. This is the module which handles the memory or saving or recovery of the state. Perfect. And in this, you have a class. The name of that class is MemorySaver. This is a very specific class which will help you create an object for checkpointers. So this is a specific class that store checkpoints in memory and that memory is RAM memory. Okay. Now we have to define the state. So we know that typedict is a very special kind of class which helps you to define a very structured dictionary where we have fixed keys and the value types. Currently, the state, my state is my state. The name of the class is my state. I'm giving two variable input and output. Input has data type string, output has data type string. I'll run it. Now I'll define my node. I have only two steps, so I'll define only two nodes, node 1 and node 2. See, step 1, it will never break. So this is my simple step 1 or node 1. See, what are the print statement? Step 1 started. What is the end statement? Step 1 completed. Checkpoint saved after step 1. These are print statement. Important point to note that I'm passing my state as state and I'm returning the updated state. That's it. Similarly, in step 2, I'm passing the state and returning the updated state. But see what I'm doing here. I'm creating a variable which will simulate the crash. Okay. And because I cannot simulate the crash in when I'm teaching you this, so I am simulating the crash, a production level crash with the help of this variable. This variable, if this variable has a value false, then the system will crash and update the variable as true. So whenever the system will run for the first time, it will crash. Understood? But not for the second time because the variable got updated. And where I'm doing it in step two. So step two, it will crash and it will enter in step two, will print this statement step two started, but will never reach to step two completed if I run it for first time. So I'm simulating that crash. Okay. Now I'm building the graph. Now, please understand when I build the graph, I have to use this class state graph. This is a very important class in the LangGraph library module because this is the class which helps you build the graph because it understands the state, it understands the nodes, it understands the edges, and it understands the workflow concepts. Okay. So I'm passing my state. This is not inheritance. I'm passing the state and I'm creating an object for this graph, which is builder. Until unless I have not created my object for the land graph or state graph, we cannot add the nodes. So now I have created the object. Now I can add the nodes and I can create the edges. Okay, now the most important point, which is very different from all the previous session. How to add check pointer. These two important lines are critical for the implementation of check pointers in the land graph. Okay, understand this is the class, MemorySaver class. It will help to create the instance for the check pointer. And I'm saving that instance or I'm saving that object in a variable. This object is check pointer underscore variable. I can name it at ABC or whatever you feel like. Now, when I'm compiling my object, state graph object, which has all the nodes and all the edges, when I compile it, then I'll pass the check pointer variable in a key that is check pointer. Okay, so builder.compile or simply compile converts your graph definition into a runnable workflow. And there you pass the check pointer to attach memory to the workflow. So here I'm attaching the memory. If you don't want to attach the memory, then you will simply write graph builder dot compile. That's it. Please watch the previous session. We never passed memory or check pointer variable inside the compile because we were not talking about persistence in the previous session. So let's remove it and run it. Okay, understand. Graph dot invoke. So I build my graph. I build my graph. Now I'm invoking my graph, but I'm passing a config. I'm passing a config, a parameter config. And in that config, I'm assigning thread ID user1 to let my graph know that you are running for user1. So this is where thread ID comes into picture. Where you pass thread ID, you pass thread ID in invoke as a config parameter, thread ID for user1. So user1, now I will invoke it. When I will invoke it, what will happen? Step 1 will run without failure, but step 2 will fail and you will not see the statement. Step 2 completed. This print statement, you will not see the statement. So let's run it. See, step 1 started, step 1 completed. Step 2 started, system failed. There is no statement related to step 2 because the way I designed the workflow, I simulated the crash. If you run this workflow for the first time, it will fail, it will crash. It crashed. Now, can I resume it? Can I resume it? Yes, I can resume it. But I want to show you something, that if there is another user, if there is another user, user 2, if he wants to invoke this graph, or invoke this workflow, then the system will not crash for it and it will run step 1 and step 2. Okay. And then what I'll do, I'll resume my workflow for user 1. And understand, when I will resume my workflow for user 1, then it will not start afresh like for user 2 from step 1. It will start from step 2, not step 1. Okay. So let's run it for user 2. For user 2, please understand the system doesn't have any information. You haven't stored data for thread ID user 2. So the system is not aware of user 2. System doesn't have any information for user 2. It only has information for user 1 till now, because you only ran user 1. See, you only ran till user 1. So when this system will run, when this workflow will run, it has no information for user 2. It will start afresh from step 1. See, step 1 started, step 1 completed, step 2 started, step 2 completed. Hello, user 2, this is the final result. But what will happen if user 1 again wants to resume because system crashed for him? So user 1 wants to invoke this workflow again. User 1 wants to invoke the graph again. Let's see what happens. What will happen? It will not rerun step 1 because it already reran step 1. So it will start from step 2 because the system crashed in step 2. And this information is with whom? With checkpointers. See, step 2 started, not step 1. Step 2 completed. And the final result is this. So this is how we implemented a very basic level of persistence in our workflow. What are the new things we have implemented here? The first was the library. The library was checkpoint.memory. The module was checkpoint.memory, and there we have used the class. We have used the class MemorySaver. That's it. This is the new class that we have introduced in this session. With the help of MemorySaver, we created a variable that holds an object for what? For checkpointers, which will pass as a value or a parameter when we'll compile our graph. This is not new. This section is new because we never passed checkpointer variable. We never created an object for class MemorySaver. This is new. What else? We never discussed about to pass config parameters in whenever we are trying to invoke, or we never discussed about thread ID. But what we are doing, we are creating a config where we have a key that is thread ID and the value is user 1, user 2, user 3, user 4. And we are passing it inside the invoke. Graph.invoke is not a new discussion. Thread ID, the key thread ID is the new discussion, and the value user 1, user 2 is the new discussion. So only three things we have implemented in this session, which is new. First is the MemorySaver object, passing the MemorySaver object in compile. And third is creating the config with a key value pair of thread ID. That's it. And that creates your persistence. Okay, I'll pause here. This is a very basic level and a beautiful way to present the persistence in LangGraph. Now, in the next session, we'll understand the short-term memory and long-term memory. Now, if I hit kernel and restart, the system will forget everything about user 1 and user 2. And that is the problem with the checkpointer. It is not the problem because checkpointers only saves information in short-term memory or in RAM. So we'll discuss in detail short-term memory and long-term memory implementation of persistence. With that, I'll pause here. Thank you. Have a nice day.